Good morning, everybody. Today we're going to be looking at factoring polynomials. Now, you may have done this in the past, but we're going to treat this as if you've never seen it before. So today's Delta Math has your first example to look just like this. The goal is to write two numbers that multiply to the value on top and add to the value on bottom. So what we're really looking at is the word factors. What are the factors of negative 96 that add to negative 4? And we're going to put those two numbers here. So you might know these answers right off the top of your head, or what you might have to do is you might have to take a look at a factor tree. What's the list of all factors of negative 96 that add to negative 4? Now, we can just create the list. I try to do an order to this, so I know that 1 will go into any number. So 1 times 96 is positive 96. We'll talk about the negative in just a second. And then I know 2 divides in evenly, 3 divides in evenly, so 3 and 32 are a factor, 4 and 24, 6 and 16, 8 and 12 are the factors. Now, if you're not sure how I got those, here's a really quick way to do it. Right? Take the number 96, try to divide it by 2. If it's a whole number, then 2 and 48 are a factor of 96. So then I took 96 and I divided it by 3. That's where 32 came from. 96 divided by 4. Notice 96 divided by 5 does not go in evenly. The other factor is a decimal. We're not concerned with that. So that's how I found the list of factors, is I just used my calculator or used my brain to figure those out. Now the question is, which of these add to negative 4? Well, notice they're all positive. A positive times a positive is not going to give me a negative, which means one of these, one of the factors have to be negative. Well, if they add to a negative number, that means the larger number is always going to be the negative one. So this would be considered a negative 96, negative 48, negative 32, and so on. So now the question is, which one of these add to negative 4, or which factors are 4 units apart? Well, right away you might be able to see that 8 and 12 are the closest numbers, and if I add those two together, they're going to add to negative 4, and that's what we're looking for. So one of the factors is 8 and the other factor is negative 12. You could flip these around and you could put the negative 12 here and the 8 here. That's it. Now, this skill is super important for the concept of factoring polynomials, which is why we're having you practice this in Delta Math first. If you look at the next example, our job is to factor the trinomial. I'm going to emphasize the box method. Well, think of it. Last week, we did multiplying. Factoring is the undoing of multiplication. So how do we set this up? That's kind of the tricky spot. Well, first thing we're going to do is we're going to set this up where we'll take the trinomial, and I know the x squared term goes here. Now right away you might be thinking, I already know the answer. What times what gives me x squared? It has to be an x times an x. Let's do that in a different color. So you might already know that an x and an x go there. Perfect. But then, now we have to think about how does the negative 2x and the 80 come into play? Well, to start, we're going to put the x squared in the first box, negative 80 in this box, and then I like to take the middle term. And sometimes I circle this because kids see that whatever that number, that middle term is in your trinomial, is always our goal. So now, just like what we did last time in the last example, technically what I'm doing, remember how if it's just x squared, there's always a 1 here? We're technically multiplying the 1 times the negative 80, and that's where negative 80 came from. So this will make a lot more sense in a couple of examples. So now I'm looking at what are the factors of negative 80 that add to negative 2. Well, notice it's adding to a negative. So when I create my factor tree, just like what we did in the last example, I know that all of these numbers are factors of 80. You can check on your calculator. If you do 80 divided by 2, you get 40. 80 divided by 4, you get 20. And notice how they add to negative 2. That means they have more negatives, so the larger factor is going to be the negative 1. So now the question is, which of these factors are 2 units apart? Well, just so happens to be 8 and 10 are 2 units apart. If I add those together, I get negative 2. So we know what those factors are. Now the question is what do we do with them? We put them in these boxes. So we can put 8x here, and we'll put negative 10x here. Think of it. If I add the 2 boxes together, they'll add to give me negative 2x. So now the question is, we just kind of undo the rest of the box. I like to think of it as kind of a puzzle. I know that the only way to get x times x was to have an x here and an x here, so I get x squared. If this has to be an x, well, then the only number that could go here is 8. 8 times x is 8x. And same thing here. The only thing that could go here to give me 10x is a 10. Now I'm purposely going to leave this negative off. I didn't write it because I want to show you what happens if you forget a negative. But notice, doesn't 8 times 10 give me 80? So far the numbers looked at match up, but the sign value's off. I need this to be negative 80. Well, the only way to get a negative 80 for these two boxes, or a negative in these two boxes, is if the 10 was negative. All right, we've undistributed or factored the box, and now we have our answer. Remember, you're not done when you fill out the box. You are done when you write your answer as a product of 2 binomials. So the original trinomial is now factored into x plus 8 times x minus 10. And if you wanted to check your work, use your box. Put in x plus 8, x minus 10, and it should all work out. So what I'd like you to do right now is go ahead and pause the video, and you have this example on your sheet. Go ahead and fill that out, and then we'll go over it here in a second. All right, now that you had a chance to try it, let's take a look. What do we technically do? Well, we're going to technically multiply the starting term by the constant term, or the leading coefficient times the constant term. So when I multiply those together, I'm looking for, this should be, what are factors of negative 2 that add to give me negative 1. Should have checked that first. All right, so let's list our factors of negative 2. Of course, that's off. This will be 1 times 2, and that's the only factors of negative 2. Now notice, when they add to a negative, that means the 2 has to be larger. So if I add those up, they will give me negative 1, and that's what we're looking for. Notice, there's always a 1 in front of just an x term. Okay, so I could have done this at the start, but what do? We put the x squared in the first box, negative 1x, your middle term goes in the circle, and negative 2, the constant, is in there. And then we just found the 2 factors, 1x and negative 2x. And notice, if I add the 2 red terms together, they're going to give me negative 1x, that middle term. So now, your job is to look at the factors. Well, notice how this is just x squared. The only way that you could get x squared is to have an x times an x. And if this has to be an x, then this has to be a 1. Because 1 times x is 1x. Notice how I put a plus. You'll see why in a second. Well, this is x on this side, and the only way to get negative 2x is to multiply this by negative 2. Now you should check your box. Notice how I didn't even look at this constant term yet? If all 3 of these boxes are true, the constant term has to be true. X times x is x squared, x times 1 is 1x, x times negative 2 is negative 2x, and the last one has to work out. Negative 2 times 1 is negative 2. So my answer is the product of the two binomials. You always should write your final answer like this. It's not, the box is just the work that we need to get it done. All right. What happens when there's a 2 in front? What happens when we have a leading coefficient other than 1? Well, the cool thing is you do the same work. The tricky part is you first have to multiply the first term and the last term together. When you do that, 2 times 35 is 70. Right? This is our target. What are the factors of 70 that add to the middle term of 19? So I'm going to do that factor tree. 1 times 70, 2 times 35, 5 times 14, 7 times 10. Now, if you automatically know the factors of 70 that add up to 19, you don't have to do this work. Right? If you're very confident that it's 5 and 14, notice they add to 19, then we can just go right to the box. So remember, your first term goes in this corner. The last term, the constant term, goes in this corner. And that middle term, I like to circle it, goes right there. And then you just found the factors. We were going to pull apart that 19x, and I say 5 of those x's are going to go on this side, and 14 of those x's are going to go here. Now here's where it becomes a little tricky. This 2 is giving us a problem. I know that the x squared is going to be x times x, but the question is, where do I put the 2? Would the 2 go here or here? Well, you kind of got to look at it. If you look at these two factors, they are not divisible by 2. So I could not put a 2 here because this would have to have a factor of 2. But notice if I go this way, 2x squared and 14x, they're both divisible by 2. So if I put the 2 on this side, that makes the first box true. It also forces this to be a plus 7, because positive 7 times 2x is 14x. And then x times 5, well, this has to be a positive 5. Some people like to put the plus here. And notice, if the first 3 boxes work, this box has to be true. 5 times 7 is 35, and we're done. So my 2 factors are x plus 7 and 2x plus 5. And then we're done. You could write these factors in any order. If you wrote the 2x plus 5 first and then the x plus 7, that's fine. All right, last one. Why don't you guys give this one a shot? Go ahead and hit pause. Okay, let's go over it. So notice, some people like to fill in the box right away. I'm completely fine with that. 5x squared, 8, and then I usually do this in a separate color. I think I used red. 22x. That's our middle term. Well, what are we going to do? We have to multiply the first and last term. So we get 5 times 8 is 40, and those are the factors we're looking for. What are the factors of 40 that add to the middle number, that add to 22? So again, if you're not sure, you can create a factor tree and you can list out all the factors of 40. But you might have figured out right away that 2 times 40 or 2 times 20 is 40, and 2 plus 20 is 22. So we're going to split up the 22 x's here, and I'm going to put 2 of those x's in this box and 20 of them right here. And then it's time to play the factor game. Okay. Now notice, I have an x squared, so I have to have an x here and an x here. But the question is, where does the 5 go? Well, 5 does not divide in 2, so I can't put it up here, but 5 does go into 20 evenly. So if I put a 5x here, then that forces this box to be 4. 4 times 5 is 20, 20x. And if this is an x, which is a single x, the only way to get a 2 is to do 2 times 2x to fill in this box. Now notice, I didn't look at this last box yet, but 2 times 4 is 8. We're done. My final answer is the product of the two binomials. This is a plus. 5x plus 2 times x plus 4. All right, your job is to do delta math. Please make reference back to either these answers that are posted in Schoology or